Welcome to differentiating inverse trig functions. So this is a follow-on from our differentiation of inverse functions, but obviously we're going to focus on trig functions. So let's have a look at y equals sine minus 1 of x, and if I wanted to differentiate that. So if we've got sine minus 1 of x, then we can, the inverse of that is to switch obviously the x and y, so x equals sine y, and the derivative of that is dx dy equals cos y, because the derivative of sine is cos. Using sine y, x equals sine y in the triangle, so sine y is equal to opposite over hypotenuse, you get x over 1. Working out the other side, so using Pythagoras, you end up with the square root of 1 minus x squared, so cos y is equal to the square root of 1 minus x squared over 1, or just the square root of 1 minus x squared. So that's what dx to y equals. So the reciprocal of that, so if you flip both sides, to y dx is equal to 1 over the square root of 1 minus x squared. So therefore the differential of sine minus 1 of x is 1 over 1 minus the square root of 1 minus x squared. If we were doing it for cos, y equals cos minus 1 of x, the inverse of that is x equals cos y, and the differential of cos is minus sine. So following the same as before, setting it up in a right angle triangle, you get minus the derivative to y dx is minus 1 over the square root of 1 minus x squared, and that's the derivative of cos minus 1. So you'll notice that sine and cos are the same, it's just the derivative of cos is minus 1 on the top when you do it. And this is important because only sine minus 1x is on the formula sheet. So the derivative of tan minus 1, so x is equal to, so do the inverse, so x equals tan of y. Derivative of tan is sec squared, and so we know that 1 with a tan is sexy, so dx dy is 1 plus tan squared x. So that makes it dx dy is actually equal to 1 plus x squared. So flipping that, you get 1 over 1 plus x squared. So the derivative of tan minus 1 of x is 1 over 1 plus x squared. The reference sheet actually goes a little bit further, and that is that it actually has what you get if you have tan minus 1, sine minus 1, or cos minus 1 of a function, not just an x. So obviously if we have x, we get the 1 on the top because the differential of x is 1. But this works for every single one of our differentials. The cos one actually is on your reference sheet. It's the integral that's not, and we'll get to that later. So let's have a go. Cos minus 1 of 3x, x squared, sine minus 1 of x on 2, and tan minus 1 of x 4. So let's just use the reference sheet. So we're doing cos minus 1 of 3x. So wherever there's a function, we're going to put 3x, and the derivative is 3, and we're just going to put that where f dash of x is. So it's just a substitution process. And you get minus 3 over 1 minus 3x all squared, or minus 3 over 1 minus 9x squared. Square root, I should say. Squared sine minus 1 of x on 2. We know that this is product rule. So, and if y equals sine minus 1 of f of x, then we're going to use the rule for it, f dash of x over 1 minus f of x all squared. So we get x squared times the derivative of sine minus 1 of x over 2 plus sine minus 1 of x over 2 times the derivative of x squared. With the sine minus 1 of x over 2, the derivative of x over 2 is a half, that goes on the top, and 1 minus x over 2 all squared is on the bottom. So we end up with x squared on the top and 2 outside of 1 minus x squared over 4 plus 2x outside of sine minus 1 of x over 2. For the third one, this once again is just simply replacing the function with x to the 4, and the derivative is 4x cubed. So the derivative of 10 minus 1 of x to the 4 is 4x cubed over 1 plus 8, x to the power of 8. Second one, Find the equation of the tangent to the curve x arctan x. Now arctan is the same as tan minus 1. So it's just a different way of writing the inverse at the point 1 pi on 4. So in this case, they've given us the point. Sometimes they'll just give us the x value, and you're going to have to substitute in to find the y value. So x arctan x is a product rule. So it's x times the derivative of tan minus 1 of x plus tan minus 1 of x times the derivative of x. So dy dx is equal to x times 1 over 1 plus x squared plus tan minus 1 of x. When x is 1, so substitute 1 in and equate. That gives us a gradient of our tangent is a half plus pi on 4, or 2 plus pi all over 4. Substitute that in and the point into our equation, y minus y1 equals mx minus x1. And you get y minus pi on 4 equals 2 plus pi over 4 x minus 1. What I've done with that next step is just multiplied the left-hand side by the 4 that's on the bottom of the fraction. So you get 4y minus pi, and then that 2 plus pi gets multiplied by each term in the brackets, and then I've just collected like terms. So you get 4y equals 2 plus pi x minus 2. Thank you.